Hello class, and welcome to day 2 of section 9.3, which is about operations with radical expressions. By the end of today's lesson, you will be able to add, subtract, and multiply radical expressions, as well as use conjugates to rationalize denominators. When you are adding and subtracting radicals, you're going to treat the radical part of the problem like a variable. So for example, if you had variables and it said 4x plus 2x, that would mean that you would have a total of 6 x's. The same thing happens when you are adding and subtracting radicals. If I have 4 square roots of 5 and I add on 2 square roots of 5, that means I have a total of 6 square roots of 5. I have 6 of the thing that was just split into a group of 4 and a group of 2. If you had two variables that were non-alike, so 4x plus 2y, you can't add those. So the answer would still just stay as 4x plus 2y. Same thing happens with radicals. If you can't simplify them anymore, so for example, square root of 5 and square root of 3 are both simplified, and they don't match, so your final answer for this would stay 4 square root of 5 plus 2 square root of 3. So you can only add and subtract radicals when you have them matching, just like you can only add and subtract variables when they are matching. So looking at this problem, we've got 10 square roots of 7 plus 5 square roots of 11 minus 4 square roots of 7 minus 6 square roots of 11. So the first thing you notice is that we have two different types of square roots that are in play in this problem. So I'm going to look at the 7s first. So I've got 10 square roots of 7 minus 4 square roots of 7. So if I have 10 of them and I subtract 4 of them, that gives me 6 square roots of 7. Then if I look at the other part, I've got 5 square roots of 11, positive 5 of them, minus 6 square roots of 11. So 5 taking away 6 is negative 1 square root of 11. 7 and 11 don't match, so this then becomes our final answer. 6 square roots of 7 minus 1 square root of 11. Go ahead and try this one on your own. You add 5 and 7 and you get 12. When you subtract 6, you end up with 6 square roots of 2. Now, this one, I've got 2 square roots of 18 plus 5 square roots of 32 plus square root of 72. Initially, it might look like we can't simplify these. But when I look at the square root of 18, I have to think back and say, is this square root simplified? We know it's not because I can take out a perfect square. So this is going to get split up into 2 times the square root of 9 times the square root of 2. Now, in order to be able to add or subtract, we want to have matching square roots. So I'm going to look at these two numbers, 9 and 2, and I'm going to say, okay, is 32 divisible by either one of those? 32 is divisible by 2, and that breaks down then into the square root of 16 and the square root of 2. This works because 16 is a perfect square. Then we look at the last one. Can that be divided by 2? Yes, it can, and we get the square root of 36 times the square root of 2. So now we have simplified all of these, and I'm going to continue by actually solving those. So the square root then of 9 is 3. So I've got 2 times 3 square roots of 2 plus 5 times 4 square roots of 2 plus 6 square roots of 2. Then I'm going to go ahead and follow PEMDAS, and I need to solve those multiplication pieces. So in the front part, I have 2 times 3, which gives me 6 square roots of 2. In the middle, I've got 4 times 5, which gives me 20 square roots of 2. And then in the back part, there's nothing to multiply, so it's just plus 6 square roots of 2. Then I can go ahead and do my addition. I've got 6 plus 20, which is 26, plus another 6, which is going to give me 32 square roots of 2. So even though these initial square roots did not look similar, we could simplify them down to something that we could add, so that we had that matching square root, and we were able to simplify. Go ahead and try this one on your own. So we're going to split it up using that common factor of square root of 5. Do your simplification, then you're going to add and subtract, and you end up with 4 square roots of 5. When we're doing multiplication, again, you are going to treat the radical like a variable. So we've got 3x times 5y. You would go ahead and you would multiply those numbers, which would give you 15, and then you would just have x, y. Same thing applies when you are multiplying radicals. We would have 3 times 5, which again gives you 15, and then the square root of x, y. The key thing that is different between square roots and regular multiplication is when you have radicals, anything outside of the radical stays outside of the radical. Anything inside the radical when you're multiplying stays inside the radical, which is why x and y are both inside the square roots. So we've got 7 square roots of 2 times 2 square root of 6. So I multiply the outside numbers, so the 7 times 2, and then I end up with 14. Then I multiply inside the square roots, which is 2 times 6, which is 12. Now I need to make sure that I cannot simplify. In this case, when I look at 12, I can divide that by a perfect square. I can divide it by 4. So I'm going to split that up into 14 square root of 4 times the square root of 3. The square root of 4 is 2. So out front, that gives me 14 times 2 square root of 3. And when I do 14 times 2, that's going to give me a final answer of 28 square roots of 3. So again, multiply the insides, multiply the outsides, then the insides, and then you have to see if your square root can be simplified. Go ahead and try this one on your own. So we end up 99 square root of 75. That can be simplified, breaking it down into 25 and 3, giving us a final answer of 495 square root of 3. We can also use distributive property while we are doing radicals. So when we're doing this, we're going to distribute. So we got 3 square root of 5 times 2 square root of 5 plus 5 square root of 3. So for the distributive property, the first part you would do 3 times 2, which is going to give you 6. And then square root of 5 times square root of 5, which is square root of 25. Then you would be adding on, multiplying the outside numbers. 3 times 5 is 15. And then the inside numbers, 5 times 3 is going to give you square root of 15. Then we're going to go ahead and see if we can simplify anything. Out front, we've got 6 times the square root of 25. The square root of 25 is 5, so we've got 6 times 5. And then plus 15 times the square root of 15, which can't be divided by a perfect square, so that square root is simplified. And then we've got 6 times 5, which is 30. So I've got 30 plus 15 square roots of 15. That is where we have to stop. Just like if you had 30 plus 15x, you can't add that to get 45x. That's not allowed because the first part doesn't have a variable. Same thing happens over here. We can't add 30 to the 15 because the 30 doesn't have a variable, a square root. So again, this is something we haven't seen yet where we have a square root just by itself. If there is a square root just by itself, that means there is a 1 in the front. So we're going to start with 8 times 1, which is 8, and then square root of 7 times the square root of 3 is the square root of 21. And then we're going to add on 6 times 8, which is 48, and the square root of 7 times 2 is 14. Square root of 21 can't be simplified, square root of 14 can't be simplified, so this is our final answer. Go ahead and try this one on your own. So the front part, when we distribute, we get 12 square root of 6. The back part, 13 square root of 4. Square root of 6 can't be simplified. Square root of 4 can. So we end up with 12 square root of 6 plus 36. Last thing we're going to talk about is what a conjugate is. So a conjugate is two opposite values that we're going to use to rationalize the denominator. So notice this first part is 2 plus the square root of 7, and the back part is 2 minus the square root of 7. So how we're going to use these is we're going to multiply them. So let's say your original fraction was 3 over 2 plus the square root of 7. This is just looking at the denominator part. We'll get to this numerator part in a minute. So to do our rationalization to get that square root out of the bottom, we're going to multiply by the conjugate, which means the opposite. That's how we got to this 2 minus square root of 7. So we're doing 2 plus the square root of 7 times 2 minus the square root of 7. So this goes back to FOIL, which we learned in chapter 7. So we're going to start by doing the first, which is 2 times 2, which gives us 4. And then the outside, 2 times negative square root of 7 gives us negative 2 square roots of 7. Then square root of 7 times 2 gives us positive 2 square roots of 7. And then square root of 7 times negative square root of 7 is negative square root of 49. Now notice, the middle part is going to cancel out. That's why we use the conjugate, those opposites. So you can skip that green step and go straight to 2 times 2, or whatever your front numbers are, is 4, minus square root times square root, which in this case is 49. Then you're going to go ahead and solve the square root of 49, which is going to be 7, and you end up with 4 minus 7, which gives you an answer of negative 3. So that is how we use conjugates to rationalize the denominator. I want you to go ahead and practice multiplying these and find the numerical value on your own. So when we do this, we have 5 times 5, that 5 squared, minus square root of 6 times square root of 6, which is square root of 36. We end up with 25 minus 6, that conjugate value then is 19. So in order to rationalize denominators with adding or subtracting, that's when we use conjugates. So notice we've got an addition of a square root in the denominator. We learned in day 1 that we can't have square roots in the denominator. So what we're going to do is we're going to multiply the top and the bottom by the conjugate, that opposite value. So we're going to multiply by 5 minus the square root of 2 in the numerator and 5 minus the square root of 2 in the denominator. Up top, that's going to be a distributive property then. So I've got 3 times 5, which is 15, minus 3 times the square root of negative 2 gives me minus 3 square roots of 2. Can't put those together because the 15 doesn't have a square root. On the bottom, we can then use our shortcut and say 5 times 5, which is 25, minus square root of 2 times square root of 2, which is square root of 4. You can go ahead then and solve the square root of 4, which gives you an answer of 2. So you've got 15 minus 3 square roots of 2 over 25 minus 2. And then you can finish simplifying that denominator, getting that conjugate value, doing 25 minus 2, for a final answer of 15 minus 3 square roots of 2 over 23. And that is how we rationalize a denominator if we have addition or subtraction with the square root in the bottom. Go ahead and try this one on your own. So our conjugate now becomes the positive value. We end up with 28 plus 7 square roots of 3 over 13. If you have questions about this or anything else from the lesson, please let me know when you get to class.